Friends, I am Chandan. Uh, this is the fourth chapter of thermodynamics, that is, first law of thermodynamics. This is my handwritten notes useful for GATE, ESC, SSC JE, ISRO, DRDO, BARC, and other competitive exam. The PDF link is given on the description. You can download it from this PDF link, and there is a Telegram link. You can join it, and like, share, and subscribe my YouTube channel. So here, this is the uh, fourth chapter of thermodynamics, that is first law of thermodynamics, or you can the first law is also known as Joule's law or energy conservation law. So what is first law? First law is say that according to the statement of first law, for a closed system undergoing the cycle, the net heat transfer is equal to the net work transfer. So for a closed system undergoing a cycle, the net heat transfer is equal to the net work transfer. So that is basically the formula is summation of Q, that is equal to summation of W. This formula is applicable only when it is a closed system and it is a cycle. So here, cycle means it may be a reversible cycle, or it may be irreversible cycle, and it is valid for closed system. So this equation is valid for closed system. Now, a cycle is said to be a reversible cycle only when all processes in the cycle are reversible. Okay, on all processes of the cycle are reversible. Okay, now let's understand the consequences of first law. Let's understand the consequences of first law. This is very important. This is very important. So the first consequences is that heat is a path function. That means heat is dependent on the path. So how? Let's try to understand. Suppose this is y-axis and this is x-axis, and here this is state 1 here, and this is state 2, and suppose first process is 1 to 2 follow this path, that is process A. This is process A, and it may go in this path also. Suppose this is process B, and it is changing from state to state 1 by following the process C. So basically here from 1 to 2, there is, from process state 1 to state 2, there is A process, B process, and from coming back 2 to 1, that is a C process. Okay, so here consider, so here so 1A to C1, this is cycle 1, this is cycle 1, or and you can say that 1B to C1, this is cycle 2. So here basically there is a two cycle, that is 1A to C1, and there is another cycle 1B to C1. Okay, now suppose this is the PV diagram. Suppose this is state 1 and this is state 2, and this is one process. Suppose this is A process. So if you want to calculate the work done, then this is the work done here. This area will be the work done for process for process A, and For process B, this is P axis, and pressure axis, this is volume axis, and this is the process B. So for process B, the area will be, so the work area for work done in process B, this is W1 B2, and for this process A, the work done is W1 A2. From here you can conclude that, from you see that the area, both the area different. So from here you can say that W1A2 not equal to W1B2. W is the work for process. So this work for process A. So W1A2, this work for process A, and this work W1B2. So this is for process B. So this work is not equal. So from here you can conclude that it is not a property. So here it is not a property, it is a path function. It is depend on the path, and it is an exact, sorry, it is an inexact differential. So here there is, you don't write this dw, don't write dw, it will be del w, or this is the symbol del w. So here 1a 2 c1, this is cycle 1, 1b2 c2 c1, this is cycle 2. Now according to the first law of thermodynamics, here for cycle 1, so cycle 1, that is 1a 2 c1, this is cycle 1. So for cycle 1, just put the formula, that is summation of q, that is equal to summation of w. So for cycle 1 means A process and C process is there. So summation of q, that is, you can say that del q 1a2 plus del w 2c1, that is equal to del w 1a2 plus del w 2c1. Okay, now for cycle 2, according to the first law, it will be for cycle 2, it is a here there is a b process and C process is there. So you can write in this way, del q 1b2 plus del q 2c1, because there is a b process and C process is there. So that is why del q 1b2 plus del q 2c1, that is equal to del w, that is equal to del w 1b2 plus del w 2c1. So this is equation number 2, this is equation number 2, and this is equation number 1. Now this equation 2 minus equation 1, if you calculate this 2 minus 1, you get, that is del w 1b2 minus del w 1a2, that is equal to del w 1b2 minus del w 1a2. So from here in first we say that here del w, here del w1 sorry w1a2 not equal to w1b2. So from here you can say that, so here del w1b2 and del w1a2 are different. So from here you can say that del w1a2 not equal to del w1b2. If it is equal, so del w1b2 is equal to, if del w1a2 del w1b2 is equal to del w1a2, then it will be 0, okay. So that is after that this will be 1, this will be equal, but here this is not 0, so that is why this is not equal. So here del w1a2 not equal to del w1b2. From here you can conclude that it is not a property. It is not a property because it is a path function, because q is dependent on the path, that means process, on the dependent on the process, that which a b process, this is dependent on the path, and it is an inexact differential. It is an inexact differential, and del you should not write dq, you should write del q, or in this way, uh, del q. Okay, now second consequences is that energy is a property. Energy is a property. This is the second consequences. Let's try to understand here del q. So from first equation, so here uh, uh, from first equation, this equation, this is written in this way here: del q, del q 1 b2 minus del q 1 a2, that is equal to del w 1 b2 minus del w 1 a2. From here you can say that del q 1 b2 minus del w 1 b2, that is equal to del q 1 a2 minus del w 1 a2. From here you can say that del q, sir, this is process b, and this is also process b, and here this is process for process a, and this is for process a. So from here you can say that del q minus del w, it is for process b, so 1 b 2, that is equal to del q minus del w 1 a2, this is 1 a2 the process. So from here you can say that del q minus del w for process b, that is equal to del q minus del w for process a. So so this is equal, this is equal, this is equal. So from here you can conclude that del q minus del w, it is a point function, and it is a property, and it is an exact differential. Exact differential means cyclic integral is equal to 0. Now if it is a closed system, then here so this difference del q minus del w, that is basically de. Okay, de, d is there because it is a property, d is there because it is a property, and here this is del because this is not a property, this is a path function, so that is why this is del minus del w. Okay, so this is applicable only when it is a closed system, and it is for a process. It may be reversible process and it may be irreversible process. So this is the first law of thermodynamics for a process. Okay, so this formula is very important. De, that is equal to del q minus del w. Now so energy here, de means change in energy. So energy means there is a three types of energy is there, that is kinetic energy, potential energy, and internal energy. Kinetic energy and potential energy is a macro form of energy, and this is the micro form of energy. Internal energy, this is micro form of energy. So here uh, if kinetic energy and potential energy are neglected, so d of kinetic energy and potential energy are neglected, so de, that is equal to d of kinetic energy and potential energy plus de. So if kinetic energy and potential energy are neglected, then d is equal to du. So this is applicable only when change in kinetic energy and potential energy are neglected. So this u, this is the u, this is basically internal energy. U is the internal energy. So here u is the internal energy. So internal energy, it is depends upon the molecular properties like molecular weight, molecular structure, and temperature. So from here you can conclude that del q, that is equal to du plus del w. So this is very important. This is very important formula. That is del q, that is equal to du plus del w. So u is the properties. So that is why it is du. It is du. Okay, this is applicable only when it is a closed system and for any process, and change in kinetic energy and potential energy are neglected. Okay, now if it is a reversible process, then dq, that is equal to du plus pdv. Okay, this is applicable only when it is a closed system, only reversible process, cross boundary, change in kinetic energy and potential energy are neglected. So del q, that is equal to du plus p dv. Okay, so this is a specific form of so here this is internal energy and this is the specific internal energy. There is a volume and this is a specific volume. Okay, so this is all about the energy. It is all about the energy is a property. Now now the third consequences is that energy of an isolated system remain constant. Energy of an isolated system remain constant. So how we know the formula? Del q, that is equal to de plus del w. Suppose consider it is an isolated system, that means this is no heat transfer. So here this is no heat transfer, q that is equal to 0. So and if so del q, we know the formula del q, that is equal to de plus del w. Now if it is insulated, that means del q is equal to 0, and if there is a rigid vessel, so that is why del w that is equal to 0. So from here you can say that de that is equal to 0, and from here you can say that initial energy is equal to final energy. So here initial energy that is equal to final energy, and if the kinetic energy and energy means is equal to kinetic energy plus potential energy plus internal energy. If the kinetic energy and potential energy are neglected, then initial internal energy that is equal to final internal energy. So if the change in kinetic energy and potential energy are neglected. Okay, so this is the third consequences of first law of thermodynamics. And here this is the last consequences, that is perpetual motion machine pmm1 is impossible. So pmm1 means perpetual motion machine of first kind. Basically this is impossible. So what is this machine? Suppose this is a system, it continuously produces work without absorbing any form of energy. So basically this is impossible. So what is in perpetual motion machine? So here it is the device which develop work continuously without absorbing any form of energy. So this is the last consequences of first law of thermodynamics. This is my handwritten notes. You can download it from the description. Like, share, subscribe my YouTube channel. Thank you.